We're going to write the electron configurations for the most stable ion formed by each of these elements when in an ionic compound. So the quantum mechanical model gives us the electron configurations of these elements, and for almost all of them, their most stable form is when they are isoelectronic with their nearest noble gas. In other words, they have the same electron configuration as their nearest noble gas. So aluminum is over here. So it has three valence electrons, two in the valence s and one in the valence p, and it's going to tend to lose those three to be isoelectronic with neon, to have 10 electrons, and to have the same configuration as neon. So let's do that. Aluminum 3 positive, and I have this periodic table that goes with Aufbau. So just fill it in the order of the periodic table: 1s2, 2s2, 2p6. So there's your electron configuration for the aluminum 3 plus cation. Let's move on to barium. Barium is an alkaline earth metal, so all those metals in group 2 have their final two electrons, have their final valence electrons in the valence s orbital. Barium's right there. So it's going to want to lose those two electrons to become isoelectronic with its nearest noble gas, xenon, with 54 electrons. I'm going to go the noble gas notation for this one. Right, so barium is going to lose those two electrons and become the barium 2 plus cation. And we can just use noble gas notation here with krypton, the noble gas before that. All right, so I've done 36 electrons represented by krypton, and then we're right here now. So 5s, 2, and then we're going to go through the 4d block, 4d10, and then we're going to go all the way through here, which is the 5p block, 5p6. If you want to, you can rearrange the 4s so the principal quantum numbers are in order, but this is good. What's next? Selenium is in this green block, so I'll go with a contrasting maroon. Selenium is a nonmetal, so it's going to gain 2 electrons. It's not going to lose 6 to get to 18. Rather, it's going to gain 2 to fill all its sublevels and get 36. So selenium is going to gain 2 and become the 2 negative anion. Again, we'll just use noble gas notation to speed this up. The previous noble gas is argon. You know what? I'm just going to get rid of this thing here, so I don't have to keep scrolling up and down to show you the Aufbau. Alright, argon takes care of the 18 electrons that argon represents, and now we're here. So we're going to go through the 4s, 2, 3d, 10, and then 4p6 to get to isoelectron against krypton. Alright, iodine, last one. Group 17. Group 17's got 7 valence electrons, so it's going to want to gain 1 more electron to be isoelectronic with its nearest noble gas, in this case xenon. So by gaining 1 electron, it's going to be 1 negative, and the previous noble gas is krypton, and then we're just going to go right through here again. 5s2, 4d10, and 5p6.